Alright, so let's take a look at graphs of our two major functions, the square root function and a cube root function. So let's get some basic shapes. That way when we look at some harder square root or cube root functions, we at least know what shape we're looking for. Because recall back last week when we were graphing, if I know what shape I'm looking for, I just keep plotting points until I see that shape. So let's make sure we know what we're looking for. That what should help you with graphing. So the square root function, the first problem is the domain. We need to make sure we're not taking the square root of a negative number. So that basically means the x that I have in there, right, the radicand, it either has to be bigger than 0 or at a bare minimum it has to at least equal 0. So interval notation, we're talking about everything starting from 0 to infinity. So negatives not allowed, right? Only positives and 0. So when I start doing my point plotting, that's where I'll start my point plotting at, right? At the location where everything starts. It's 0. Well, the square root of 0 is 0. So 0, 0 is on my graph. Taking a look, what's another nice square root we have is 1. So the square root of 1 is 1. Another nice square root value is 4, right? So the square root of 4 is 2. So I get that. Let me do one more. 9. The square root of 9 is 3. So we get that. And we can keep going further, but I think, again, usually 3 or 4 points gives us an idea, and we can take it from there. It just keeps on going on forever. So plotting what I have, I got 0, 0 on the graph. I've got 1, 1 on the graph. I've got 4, 2 on the graph. And I got 5, 6, 7, 8, 9, comma 3 on the graph. So as we keep getting bigger along our input of x's, it looks like the outputs are steadily climbing upwards. And that's a classic situation for a square root graph. It has a limited domain, and really what it is, as you guys, as we move through our math careers, what you're actually looking at is a parabola that is laying down. And the square root will always be one of these halves. Right now, since we're talking the principal square root, it's always going to be the positive half. So we're not going to be graphing that one until your 150 classes or whatnot. But I just wanted to get you guys a feel that the square root graph, what it classically is like the top half of a laying down parabola. So that's what we're looking for in a graph. As soon as you have that, start off with where the graph, the domain starts. That's your initial data point. List values that give you some nice square roots, and then you can basically plot that half looking laying down parabola looking shape. So what about a cubic graph? Well, what we know about a cubic graph is its domain's very strong. You can plug in whatever you want. Cubics handle negatives and positives just fine. So it doesn't really matter. So what are some nice cubics? Well, negative 8 is a nice cubic, right? Because the cube root of negative 8 is negative 2. Negative 1 is another nice one, right? The cube root of negative 1 is negative 1. 0 also is nice, right? What's the cube root of 0? Well, it's just 0. 1 would give us 1, and 8 would give us 2, right? Cube root of 1 is 1. Cube root of 8 is 2, right? So I'm plugging the data into the function that's given. So again, we can go on forever, but let's see where these 5 data points give us. We have negative 8. 1, 2, 3, 4, 5, 6, 7, 8, negative 2. We've got negative 1, negative 1, 0, 0, 1, 1, and then 2, 3, 4, 5, 6, 7, 8, and 2. So if we kept going on in either direction, the graph is just going to keep on going forever this way, and it's going to keep on going forever that way. So it's kind of like an S shape that's been elongated. And that's a classic shape or a classic situation for a cubic graph. That's exactly what they look like. Again, a very strong function. You can go on forever, positively or negatively. You're just going to keep elongating that S shape as you go along. So it's kind of a nice elongated S. So those are the shapes we're looking for. Let's go graph some tougher square roots and cubic functions.